So good day class. So welcome to our Building Technology 3 lecture on weeks 5 and 6. So I understand that I'm your instructor also in plumbing, and we have a lot of plates on our hands, so that's why I'll be reducing our requirement for Building Tech 3 from uh, 4 plates to only 2, which is around 1 per week. Okay, so for weeks 5 and 6, I will require you to produce S5 and S6. Let me open it. Okay, S5 and S6 of the plans that you could see in our use step. This is all prepared by architect Gerald Harayo. Let's go to S5. So here class, at S5 you can see our schedule of roof beams. Okay, so when you say class roof beams, so these are the beams which will support your roofing structure. Okay, so you have beams which support your floor, then above it are the beams which support the weight of the roof. Okay, so in the design of these beams class, it would depend on how much weight your roof structure carries. So if you have a roofing structure that is uh, made up of concrete tiles, then expect that the design of your roof beams would be in such way that it could carry the load too. Okay, so here, so let me just okay, zoom this one. Okay, so these are the different type of beams. Okay, the tie beam class is what you can see at the ground level. So it connects all the columns together so that it would act as one system. The advantage of excuse me of having a tie beam is that your uh, system of columns won't move individually. Because if one column structure sinks, then it would affect the entire house. But if your columns are connected by a tie beam, then it's like acting as a single system. Okay? So it will help reinforce each other. So so these are our schedule of beams. We have 2B-1. Its width is around 250 and its length is around 400. Okay. Then at the top bar, it has three 20 mm diameter bars. At the bottom bar, it has two 20 mm diameter bars. And at the midspan, the top bar are two 20 mm diameters, and the bottom bar are three 20 mm diameters. Then at the right support, it's three 16 mm diameter and two 16 mm diameter. Okay, so in the schedule of beams, you can see here in this area the width, the different widths and the different lengths, and you can also see the reinforcements. Okay, and of course the spacing of the different stirrups. So here 2 at 50, 3 at 100, 3 at 150, and the rest at 200 mm. Okay. The diameter is around 10 mm. So that's the meaning of the schedule of beams class. Okay. So here it has at N over 5, this is at support, this is the total length. Here you can find the 10 mm stirrups at 2 at 50, 3 at 100, 3 at 150, and the rest at 0.2. Okay, so it's written here. So instead of doing something graphical like this one, so you write it in the table. manner like this. Okay. And then of course, okay, at supports, okay, so this is the drawing. 320 mm at the top, then 20 mm at the bottom. The size is around 0.25 by 0.40. So these are the stirrups, the 10 mm stirrups, and this is the spacing for the stirrups. So at mid-span also class, it's also the same. You have here the height, and this is the width of your beam. The top you have 220 mm, 320, and then at the bottom at 320 mm. So as you can see at support class, okay, it's just inverted. Okay. There's a technical reason for that, and you will learn that when you reach your theory of structures. It's going to be explained to you in detail when you're going to compute the steel reinforcements for your building. So I think this is for S5. Let me zoom this out. Okay. So in total class, in this sheet, you can see the schedule of beams, the typical reinforcement beam details, then a graphical drawing on the beam at the midspan and at the support. Now let's go to the S6. At S6 class, I think you could just find the drawings as well. So this is beam 2B2. This is at beam 2B3. Okay, so it's the same explanation that I gave earlier. So at support, it's at the top, but the difference is that here it uses only 4 12mm bars. The bottom is at 2 12mm bars. Okay, I think the previous detail it has 20 mm. Then again, the sizes of the reinforcement it would depend on the computation of the structural engineer, and which could be determined through the structural analysis. Okay, so there's a computation for this one class. You'll learn in theory of structures when you reach your steel design. Okay. But here class, in our building technology, you will be oriented just on the details, okay, on how to prepare them. Okay, so this is 2B2 reinforcement concrete beam. So NTS means it's not drawn to scale. So there are times that when you don't draw it in scale. What's important is that the ones reading the plans understand what they're going to implement in the site. I think the same could be repeated for this one. So this is a fairly easy exercise. Okay, that's so okay. I think I may need to show you an example of a structural layout. Okay. Okay. So when you prepare your structural plan, of course, you have your structural notes. In the structural notes class, the source of this is usually the National Structural Code of the Philippines, or NSCP. So you're going to write the instructions there. Okay. So this is an example of how to do, of another way to do it. Um, if your structural design is, the structural design of the structural engineer is uh, somewhat different at different lengths, so this is one way to present them. Okay, so this is done in AutoCAD. So you can write from point 3 to 1.5 that this is the drawing. This is the how the reinforcements are going to be arranged. Okay. Okay. For example, for this one, it's like this. Okay. Yeah. So I think this is a little bit complicated for you guys. So just focus on the presentation, because this is how it was prepared by our structural engineer. So there are different designs for the beams depending on the height that it's on. Okay, so this is the beam plan. So you can see here the different beams. You have here B5A, B5B, B5C. Okay, so it's from A to D. So, so it's beam 5D. Okay. Here it's beam 7A. So it's different. So the design is different for this beam uh, from B5D. So B7A has a different design from B5D, and then has a different design from B3C. So it would really depend, class, on your structural engineer, and it would also depend upon the site conditions as well. Okay, so second floor beam plan. Okay, so this is how it was prepared, and it has also a table. So here it's presented in a different manner. It also shows the cutting length, the dimensions, and the blow up of the stairs. So usually the height that's good is 0.1875, and then the width is the minimum is zero point 0.3. So here it's only 0.25 because there's a zero point 0.05 nosing here, so this totals around zero point 0.3, which is the, I think, what is required in the NBCP. Okay, so let's go back to S5. Okay, class, so let's wrap it up. So for our S5 and S6, prepare the schedule of beams and then the different reinforcements as well for the S6. So I already reduced some of the requirements because I think I gave you drawing requirements as well in plumbing, in our plumbing subject. Okay, so just for humanitarian consideration since we are in a pandemic. But despite the situation, class, I hope that you will strive to learn the skill that is necessary. Because honestly, I think it would be much easier for me to teach you if I can see you all at once in a classroom setting. But at last, we are in a pandemic period, so you have to uh, work as well and practice your hands. Okay, so see you next meeting, class. If you have any further concerns, questions, or clarifications, feel free to reach out to me anytime. Okay, so see you next meeting.